All right, hello. Welcome to this video, I guess. Today we're doing a worksheet on solving equations. And I did post the solutions on Google Classroom, but apparently that was not very helpful to many of you. And you'd prefer a kind of, I guess, video walkthrough, maybe an explanation by voice would be a little bit more helpful. So yeah, I guess. Okay, so it is a confusing topic, so don't feel bad if you didn't get it right away. It does take some practice. So let's go through it together and let's see if this would make a bit more sense if it's explained to you verbally. All right, so question one, we've been given an algebraic expression. So that just means we've got a thingamajig here with some letters, right? If you see you have this x here, you have a y, okay? And we don't know what it is yet, okay? But you know, there's exponents, there's a division, it's a fraction, there's multiplication going on here. There's a negative sign, okay? But basically, what it is they've given us this the numerical values of x and y, okay? So we know what x is equal to, and we know what y is equal to, and we want to know what's the numerical value of the expression, which means I want to know what this expression actually comes out to as a number. And to figure that out, we're just going to, rewrite this exact thing, but wherever we have x's, we're going to replace it with the -6, and wherever we have y, we're going to replace it with a 2. Okay, now for these types of questions, I like to be very careful to make sure that I don't mess up the substitution step. So what I'm going to do is I'm going to use brackets just to help me out. So let's put the little negative sign here first, right? So there's a little negative sign. Let's put that right there, okay? And what I mean by brackets is here we have x to the 3. So instead of x, I'm going to open bracket, put that little -6 there, and then put the exponent 3. And then instead of y, I'm going to open bracket, put a 2 there, and then put a little fraction, 3, and then once again, I'm going to put the open bracket 2 squared. Okay, so I replaced my x with a -6. I replaced my y's with 2's. Now, okay, we still have that negative sign in the front. We're going to slap that right there. Now, let's do -6 to the exponent 3. Okay, so very careful. The exponent doesn't mean that we're multiplying the -6 by 3. It's not -18, okay? It's -6 times -6 times -6. That's what an exponent is. It just means it's repeated multiplication by itself. Okay, so be very careful. Don't just multiply the -6 by 3. So -6 to the exponent 3. Okay, you can use a calculator for this. Or if you want, you can do like -6 times -6, which is positive 36. And then you just do 36 times -6 again, okay? Make sure you use brackets here, all right? And that's going to give you -216, okay? So we've got -216 up top here, and a 2 over 3 times, and then 2 squared is going to be 4, right? And so now what you'll notice is on top we've got 2 negatives, and they're being multiplied together, so that's going to cancel out. So the 2 negatives, let me change color real quick. Okay, this one right here, they're going to cancel out. Like that, gone, okay? And so 216 times 2 is going to be 432. And in my denominator, I have 3 times 4, which is 12, okay? And so all I do now, because I know a fraction is just a division, I just do 432 divided by 12. That equals 36. So I'm going to go to my answers here, and which one is 36? This one right here. So I'm going to circle D, okay? So I'm going to move right along to question 2. Let me get my blue marker back here. Okay, so question 2, same idea, basically like almost literally the same question. It's just we're plugging in different numbers, and we have a third variable, all right? We have this z as well. So what I'm going to do, once again, just use my brackets here. Okay, be very careful with how you're substituting these in. Okay, instead of x, I've got 6 now. Instead of y, I've got 8. I'm going to do -16 times, instead of z, I've got -5. And I'm going to divide by 4. Okay, now 6 times 8, that's just going to be equal to 48. Now I have -16 times -5. Let's draw that a little nicer. -16 times -5. I've got the multiplication of 2 negatives, so that's going to turn into a positive. And 16 times 5 is just 80. And now I'm going to divide by 4 again. Okay. And so 48 plus 80 is 128 divided by 4, which comes out to 32. Okay, so your answer for this one is going to be C. Now on to question 3. So question 3 says, for which of the following equations is x equals minus 2 a solution? So there's really two ways to go about doing it. Okay, the first way is you can solve these 3 equations and see if you actually get x equals minus 2 as your answer. All right, so that's the kind of straightforward way of doing it. You solve all these as if they were just solving questions. Another way you can do this is to substitute, kind of like what you did for questions 1 and 2. You substitute the x equals minus 2 back into your solution, into your equation. Now, if you remember from the very start of the chapter, I said a solution is something that makes the equation true. So if you end up with something, an equation that is not true, then x equals minus 2 is not a solution. Okay, so that might be a little confusing. Let's show you what I mean by that. All right, so if I go to my first option A and I replace my x's with minus 2's, I'm going to get, on the left, I'm going to have 5 minus 3 times minus 2. And here, the 5 stays the same, but here, because I have multiplication, that has to happen first, right, because of bedmass. So minus 3 times minus 2, so I have multiplication of 2 negatives, that's going to be plus 6. I'm going to end up with 11. So on the left side here, I actually get 11. And that's going to be equal to something. I don't know what that is yet, but let's replace my x here with a minus 2. I'm going to have minus 2 plus 1. That's going to be minus 1. So on the right, I have minus 1. Okay. So now let's think about this. 11 equals minus 1. Those are two very, very different numbers. Okay, so actually they're not equal. 11 is not equal to minus 1. So this is not a true equation. So for A, the x equals minus 2 is not a solution. Okay, it does not make the equation true. Now let's try C, okay, because I don't know, I'd like to go left to right. So let's plug in x equals minus 2 into the x's. But first of all, on the left, okay, we have two x's. These are like terms. How about we just combine this first, and then I'll substitute the minus 2 in. I know minus 2 plus 6, I know these are like terms because there's the x's, and they're both exponent 1. So 6 minus 2 is just going to be 4. On the left, I have 4x, right? These two combine. So I'm going to replace the x here with a minus 2. So 4 times minus 2 is going to be minus 8, right? And on the right here, I'm going to replace the x with a minus 2. I've got 8 times minus 2 is minus 16. And minus 8 is not equal to minus 16. So it's not C either, right? This is minus 8 equals, and that's minus 16. Okay, so not equal, it's not C. How about B then? So we've got 6 minus 7 times minus 2. Because of order of operations, I have to multiply this first. So we've got 6 minus minus turns into positive. 7 times 2 is 14. So 6 plus 14 is 20. So on the left, I've got 20. And on the right, I've got 22 plus minus 2, which is just like 22 minus 2. That comes out to 20. So I've got 20 equals 20. And 20 is equal to 20. So x equals minus 2 does make a true equation in B. This is true. 20 is equal to 20. So x equals minus 2 is a solution for B. Same idea for question 4 here. Okay, so it says, for which of the following equations is x equals 9 not a solution? So basically now I'm going to do the exact same thing as for question 3. But now if I get a true solution, so I get something like 20 equals 20, then that's not your answer. Okay, so it's a little bit weird. Let's go through it again. All right, let's try A. All right, so we're going to do minus 13. Maybe I'll use a different color so I just don't get confused with the work from question 3. Let's use green. So we've got minus 13 times 9 minus 27 on the left, and on the right I've got minus 16 times 9. So on the left, if you punch that into your calculator, you're going to get minus 144. And on the right, you also get minus 144. Okay? So on the left, you have minus 144. equals, and that's minus 144. So this is a solution, so it's not your answer, right? Because we want where it's not a solution, okay? So make sure you're reading the question very carefully. Now, I guess just to spike, just to be different from question 3, let's go to go from A to B, okay? So A to B, because I know for question 3 we went A to C, and that was a little weird. So let's go try B. So we've got minus 5 minus 9 is equal to, and this is 14 on the right, but I'm not going to do that yet. Minus 5 minus 9 is going to be minus 14, and on the right we've got positive 14, and last time I checked, negative 14 is not the same thing as positive 14, right? Imagine negative 14 as the temperature outside. That's very different from positive 14. So the negative sign changes a lot. So actually for B, x equals 9 is not a solution. These are not equal. So your answer is B. Okay. Now question 5. All right. So for these types of questions, I would like to recommend to read the question, just very, very carefully. Read the word problem. Make sure you're really understanding the story. And when you set up your equation, to kind of think about what it is that is equal. Okay. Remember, an equation means two things that are equal. The left is equal to the right. Okay. The hint is in the name, right? An equal sign. So let's look at question 5. So Drake and Jen are selling reusable water bottles for a school fundraiser. The following information is given. Drake sold 2 bottles less than 5 times the number of bottles sold by Jen, and Drake and Jen sold a total of 58 bottles. Which of the following equations represents this situation? So for these types of questions, okay, read the question carefully. Make sure you're defining your variables, okay? I've said this before in the past unit, in a prior unit, but I don't think anyone carried that over to this topic. But it's really important that we're defining our variables, okay? Very often I'm going around, I'm seeing you guys do your work, and I'm like, what is x? What are you writing? What does this equation mean? What does this expression mean? And you guys can't tell me. So it's really important that you define your variables, okay? You let me know what that variable means. So in this question, let's think about it. We know Drake sold 2 bottles less. Okay, so it's 2 bottles less than something. Now, this really frustrates me. So I need you guys to listen up, okay? If you're actually watching this video and you got to this part, and you're just kind of zoning out right now, lock in, okay? If you sell 2 bottles less than, okay? Just think about it this way, right? It's if I want to know what's 5 years less than your age, right? You're not doing 5 minus your age. You're doing your age minus 5. It's something minus, okay? So if I say something is 2 bottles less than, okay, that means we're taking 2 bottles away from something. So don't do 2 minus 5x, okay? That's not it, okay? It's 2 bottles less than 5x. So it's 5x minus 2, for example, okay? But I didn't define what x is yet, so let's not do that right away. But yeah, so anyway, it's 2 bottles less than something, so we're subtracting 2, okay? We're going to subtract 2 from something. Subtract 2, okay? Now we know it's 2 less than 5 times the number of bottles sold by Jen. So basically, we want 5 times the number of bottles sold by Jen, and then we're going to subtract 2 from that. But do I know how many bottles Jen sold? And the answer is no. They didn't tell us that. So what I'm going to do is I'm going to go over here, the number of bottles sold by Jen. I'm going to say, yeah, that's my x. Okay, x is the number of bottles sold by Jen. So then to write the number of bottles sold by Drake, so I can write number bottles by Drake. Okay, I'm going to write 5 times the number of bottles sold by Jen, which is x, and then I'm going to subtract 2. Okay, so that's the first kind of highlight, the really big thing I need you guys to do is to define your variables. X is the number of bottles sold by Jen. The number of bottles sold by Drake is 5x minus 2. Okay, but we don't have an equation yet. We haven't written anything. So don't start solving. Don't start adding 2 and canceling this out and getting 5x plus, oh, what is that? 5x plus 2. Okay, there's no equation. There's no equal sign yet. We can't solve yet, right? We need an equation. So don't jump the gun. Yeah, okay, hold your horses. Okay, so we've got 5x minus 2. That's the number of bottles sold by Drake. We know x is the number of bottles sold by Jen. let's read the next sentence. It says Drake and Jen sold a total of 58 bottles, meaning if we combine X and the number of bottles sold by Drake, so the number of bottles sold by Jen is X, the number sold by Drake is 5X minus 2, we get 58, right? So forget about your variables for a second. Let's say Jen sold 5 bottles, Drake sold 10 bottles. How many bottles do they sell in total? I would add them up, right? You add these two numbers up to get your total. So I'm going to take the number of bottles sold by Jen, which is X. I'm going to add that to the number of bottles sold by Drake, to 5X minus 2, right? This right here is Jen. This right here is Drake, okay? So I see a lot of people, they're circling like B, for example, okay? But you've completely left out the number of bottles sold by Jen. And you would notice this if you define your variables, right? Because if I look over here, I have 5X minus 2, right? That's just the number of bottles sold by Drake. And you wrote here, if you circle this, 5X minus 2 equals 58. But it doesn't say that Drake sold 58 bottles. It doesn't say that. It doesn't say that 5X minus 2 is 58. It says Drake and Jen sold a total of 58 bottles. So you have to take this and add it to this, okay? This isn't equal to 58. It's the sum of these two things. You have to add these two things, right? So if you define your variable, you show all your work, you understand what this expression actually means, you won't accidentally circle B, okay? It's not the number, this is just Drake, right? And it does, like I said, it doesn't say that Drake sold 58 bottles. It says Drake and Jen sold 58 bottles. So it's not this, okay? It's whatever I wrote on over here, okay? So this is equal to 58. But we're not done yet because we have two like terms on the left. And we can combine these two. That's going to give you 6x minus 2 equals 58. And so your answer would be C, okay? Now on to question 6. So consider the square and rectangle given below, okay? The area of the square is 196 centimeters squared. The width of the rectangle corresponds to a side length of the square. So basically it's saying that this x and this x are the same x, okay? Well, they're the same variable. So basically, if I know what this x is, I know what that x is, okay? And the question says, what is the area of the rectangle? Now remember, the formula for the area of a rectangle is length times width. And we have the length, it's 70, right? That's fine. But we don't have the width. This is something we don't know, right? So ideally, we would find out what this x is and then multiply it to 70. And how do we find that x? Well, we're going to look at literally the only other thing that they've given us in this question, which is the square, okay? We have the square. We know the area of the square is 196 centimeters squared. So how do I find the area of a square? It's not the square, it's not this 196 divided by 4, okay? It's not that, okay? That's if they gave you the perimeter, and then you divide that by 4 because the perimeter is the length around all the sides, and you know that each side is the same length, so you divide by 4, fine. But right now we don't have the perimeter, we have the area, okay? How do we find the area? The area is the side times itself, right? It's just, if I have a square here, and I told you the side was 8 centimeters, you'd see the area is 8 times 8, which is 64 centimeters squared, right? So you just take the side and you multiply it by itself. So basically, something times itself, x squared, is equal to 196, okay? And how do you find x? There's two ways, okay? The first way you can do it is just trying numbers. So we know, for example, that 144 is 12 squared, right? 12 times 12 is 144. So we have to try a number that's bigger because 196 is bigger than 144. So let's try, I don't know, 13 times 13. What is 13 times 13? It's 169. That's not 196. Next, let's try the next number. What's 14 times 14? Well, 14 times 14 is 196. So 14 squared is 196. X is equal to 14. Okay, now I know my x by just trial and error. Another way you can do it is by just taking the square root of 196, right? Remember, the square root just means it's just going to give you the number that when it's times itself gives you 196, which is automatically going to give you 14. So x is equal to the square root of the area. That's just 14, okay? Now that I know the side length, I know this is 14, x equals 14. I can find my length times width, right? I can fill that out. I've got 70 times 14, okay? And if you put that into your calculator, I believe you should get 980, okay? And so your answers then were, if I remember correctly, it was like D, C, B, B, C, and then like C again. Okay. Now on to part B. All right, so this is kind of like where the fun begins here, right? So we are given some equations, okay, and they just kind of want us to solve the equation. All right, so let's just jump into it, I guess. So what is the numerical value of x in equation 1? Basically, it just wants you to know, it just wants you to figure out what is x equal to. X equals a number. What is that number? What is that numerical value? Okay, so let's look at question 1, or equation 1. Step 1 here is just to distribute, okay? So let's distribute. We have brackets here, so let's distribute. The number in front of the brackets gets multiplied to both things on the inside, okay? So 4 times x is 4x. 4 times minus 10 is minus 40. And we still have that minus 2x plus 5 equals 35. Okay, now before we get to eliminating anything, let's just combine like terms on either side of my equation. On the right, there's really nothing to combine, so let's just look on the left side. If you're confused, draw a little line so you can see what's on what side, okay? So it's very obvious, clear as day, the two sides of the equation. Now on the left, we've got 4x. We've got this minus 2x here, right? So let's combine those two. 4 minus 2 is 2, so we've got 2x. Minus 40 plus 5 is minus 35, and that's going to be equal to 35. Okay, so my x is over here. On the left, I want to get rid of this 2. I want to get rid of this minus 35. We have to get rid of the minus 35 first, right? Because remember, the 2 and the x are being multiplied together, okay? So we're undoing the operations in reverse order. Multiplication happens first, subtraction happens next. So subtraction is the first thing I'm going to undo. So let's get rid of that. We're going to add 35. We're going to add 35. This goes away. We get, I'll write over here because I'm running out of space, 2x is equal to 70. Okay? And now we can undo that multiplication by dividing. Divide this side by 2 as well. We get x is equal to 35. Okay. Now on to the next question here. We've got a lot of fractions, which is a little bit annoying, but it's okay. I'll show you a little trick, and hopefully as you move forward, that trick will help you in other things. I don't know. So let's look at this one. We've got some fractions. Remember, this is the same thing as 8 over 1, right? Now, if we look at this kind of equation, there's really nothing to distribute. If we try to divide, we're going to get a bunch of decimals, which you might not really care about. But that's not like the nicest thing. But what we could do is we can try and eliminate one of these y's, right? We've got a double-sided equation here, right? So let's draw a little line. We've got y's on the left and on the right. So we have to get rid of one of them. I'm going to choose to get rid of this 3y over 4 because I know 3y over 4 is smaller than 3y over 2, and that way I don't have any negatives. Okay, so let's do that. We're going to subtract 3y over 4 on both sides. So we've got 3y over 4 minus a half. And I'm going to subtract 3y over 4 so that these cancel out. And this is going to be equal to 3y over 2 minus 8 over 1. And I'm going to put in that minus 3y over 4 on the same line. Okay, doesn't really matter where you put it on the same side of the equation. But you can see now we've got a little line here that's going on. That's not a 2, it's a 4. Okay, miswrote that completely. Just making sure you guys are paying attention. And now the next thing you have to remember from fractions is we can't subtract these yet, right? Because they're not on the same denominator. So let's get them all on the same denominator. I have to multiply the top and the bottom by the same number so that the fraction remains the same, right? It's an equivalent fraction. So how do I get all of these to a denominator of 4? Let's start with this guy. The denominator is 2. To get the 4, I have to multiply it by 2. So I'm going to get minus 2 over 4. Over here, same idea. We're going to get 6y over 4, right? Multiply by 2, multiply by 2. Here I'm going to multiply by 4, and 4, I'm going to get 32 over 4 minus 3y over 4. Now the trick that I want to mention is if you're solving an equation, okay, and this only works when you have an equation. If you're solving an equation and everything has the same denominator, as you can see here, they all have the same denominator, we can just forget about the denominators, okay? Because basically what we're doing is we're multiplying everything by 4. So like it just really doesn't matter, okay? They're all gone. So what we're left with then is minus 2 is equal to 6y minus 32 minus 3y. And let's just combine like terms. 6 minus 3 is 3. We got minus 2 equals 3y minus 32. And now we solve as usual, right? Y is on the right now. We want to get rid of the 3 and the 32, but I know the 3 is being multiplied, so I have to get rid of the 32 first. I'm going to add 32 here, add 32 here. This goes away. I'm just left with 30 equals 3y. And now to get rid of this multiplication, I'm going to divide both sides by 3. I get 10 is equal to y. Okay, oops, like that. Okay. So that's that for question 7. So let's go to question 8. Okay, so question 8. Step 1, let's see if we can distribute or divide. No, not really. Step 2, let's combine like terms. Let's look on the right. It's just a 32, right? Nothing really to combine. But on the left, we've got a couple like terms, right? We've got this 5x and this minus x. We've got this minus 6 and this plus 10. So let's combine those two. 5 minus 1 is 4, right? Remember, if there's nothing right in there, it's like there's a 1. So 5 minus 1 is 4. We've got 4x minus 6 plus 10 is 4. So we've got plus 4 equals 32. Okay. And now we are going to, solve as usual. We've got 4 times x, and there's an addition of 4. So, addition happens last. So let's get rid of that first. So we're going to minus 4. We're going to minus 4. That goes away. We're left with 4x equals 28. Divide by 4, divide by 4. That goes away. X is equal to 7. Okay. Let's look at this one. So step 1, distribute and or divide. I know I should distribute. I have these brackets here. Okay, so take that little 6, multiply it to both things on the inside. We get 6y minus 42. I see a lot of people distributing, and then the y or the x just disappears. I don't know where it goes. I'll be so honest with you. I've never understood why it disappears. It's like if I multiply 6 by any number, it doesn't just become 6, right? That only happens if the variable is 1, but we don't know what the variable is equal to. So I don't know why your variable just vanishes. So be very careful about that. It doesn't just disappear. It's not a ghost. Okay, the y is still there. It doesn't just disappear. Okay, and then here we've got the minus 2y equals 58. Okay, now let's see if we've got any like terms. Yeah, we do. We've got this and this. So that's going to become 4y minus 42 equals 58. Now we've got multiplication, we've got subtraction. Let's get rid of the subtraction first. So plus 42 plus 42. 4y is equal to 100. Divide by 4, divide by 4. Y is equal to 25. Okay. And that's it for question 8. Oh, I just have to scroll down so you guys can see. That's my bad. There you go. Yeah. Take a second, write that down, I guess. I don't know. Yeah, sorry, I was writing off screen. Okay, question 9. So here we've got some word problems. And like I said, word problems, just read this very, very carefully. Make sure you're understanding the story. Make sure you're understanding the problem itself. Okay, always define your variables. Okay, if you don't define your variables, it's very, very difficult for me to understand what you're doing. And I'm sure it's going to be very, very difficult for you to understand what you're doing. And it's going to be even more difficult to even set up your equation in the first place. Okay, so let's read this question carefully. Jim has 28 red and blue pens in total. So meaning he's got 28 pens, and they're either red or blue. Okay, he has 28 pens. I don't know how many are red, how many are blue. I see a lot of people doing 28 divided by 2, okay, which is wrong because it doesn't say that he has an equal amount of red and blue pens. So yeah, don't do that. Okay, so he has 28 pens. I don't know how many of each he has. But I know one thing. I know the number of red pens is 4 more than. So let's stop right there. Let's pause right there. 4 more than. So once again, let's come up with a random example. Okay, let's say I have like 12 books and I want 4 more. Right? I would just add 4. I would just add 4 to that number. So I would just When I say 4 more than, that means I want to add 4 to something. Add 4 to something, okay? What am I adding 4 to? I'm adding 4 to 3 times the number of blue pens. Okay, so I'm adding 4 to 3 times the number of blue pens. Do I know what's the number of blue pens? Not yet, right? So let's say the number of blue pens is X. I don't know what that is, so I'm going to call it X, okay? And so if I know number of blue pens is X, then the number of red pens is, like I said, 4 more than 3 times the number of blue pens. So I'm adding 4 to 3 times this. So what's 3 times X is 3X, and I add 4 to that. Okay, now how many of each colored pen does Jim have? So I need to set up an equation. So I've used this sentence already in the question, so that's done. I've used up as much information as I can gather from that sentence. What other sentence is in the question is Jim has 28 red and blue pens in total. Okay, whenever I see that in total, that means I'm going to add things, okay? Like I said, if I forget about the variables for a second. Let's say I have 10 red pens and 10 blue pens. I have 20 pens in total. How do I know that? I just added the two things together, right? So just because this looks fancy, okay, fancy schmancy, don't do 3x plus 4 equals 28. This is wrong because 3x plus 4 represents the number of red pens, not how many pens he has in total. It doesn't say Jim has 28 red pens. It says he has 28 red and blue pens in total. So it's not just 3x plus 4 equals 28, because 3x plus 4 is the number of red pens. Okay, what is actually equal to 28 is when I add the number of red and blue pens. If I do x, which is the number of blue pens, plus 3x plus 4, that's equal to 28, right? This is the number of blue pens, that's the number of red pens. Great. Now, let's combine like terms. Okay, we've got x, we've got 3x, that's going to be 4x plus 4 equals 28. Subtract 4, because I want to get rid of that 4 first. That's what's happening last on the left, right? So that's going to cancel out. We get 4x is equal to 24. And then divide by 4, x is equal to 6. Now, a lot of people got to this step and went, I don't know what to do now. X is equal to 6. Does that 6 go here? Does that go here? I don't know, right? But if you did define your variables, if you were very careful about this and you actually wrote what x was like I did, okay, I know the number of blue pens is x. So if x is equal to 6, then the number of blue pens is 6, okay? Now, how do I find the number of red pens? Well, what you can do is you can go back to this thing that you wrote, this little expression, and you can replace the x with a 6. Okay, and so here you get 18, right? 3 times 6 is 18, plus 4, you get to 22. Or what you can do, which is I think a lot easier, is just take your total, 28, and you just minus the number of blue pens, and you get 22 anyway. Okay, but both ways work, so you pick. Okay, question 9. So Monica has 289 books in total, right? The number of fiction books is 54. Less than. So 54 less than what, right? So remember, when I say less than, that means we're not doing 54 minus something, okay? When I say 54 less than, that means I'm going to subtract 54 from something. Okay. I'm subtracting 54 from something. What am I subtracting it from? I'm subtracting it from 6 times the number of nonfiction books. So, do I know the number of nonfiction books yet? Not yet. So this right here, the number of nonfiction books, that's what I'm going to call x, okay? The number of nonfiction books. And so now that I know x is the number of nonfiction books, maybe I'll write that the other way around so it looks a little nicer. Okay, so number of nonfiction books is x, okay? Then I can now write an expression for the number of fiction books, right? The number of fiction books is equal to 54 less than 6 times the number of nonfiction books. So 6 times what? 6 times the number of nonfiction books, which is just x. Okay, and now I'm going to subtract the 54 from that. Now it says how many types how many of each type of book does she have, right? And so once again, this looks very fancy, okay, but doesn't mean that this is equal to 289. Read the question very carefully. It says she has 289 books in total. So it's not, she doesn't have 6x minus 4 should have 289 fiction books, because this expression, 6x minus 54, is just the number of fiction books. It doesn't say she has 289 fiction books. It says she has 289 books in total, which means if I take the number of nonfiction and fiction and I put them together, okay, in total, I have 289. So it's x plus 6x minus 54, which is equal to 289. Now we combine like terms. X plus 6x is 7x minus 54 is equal to 289. Okay? Now at this step, remember, we've got multiplication, we've got subtraction, right? And what happens first is the multiplication, right? Remember, when there's a number and a variable together, it's like there's a multiplication. Okay, so we have to get rid of the subtraction first. We add 54. We add 54. Here, that's going to cancel out. We're left with 7x on the left, and that's going to be equal to 343. Now, we just divide by 7. This cancels out. X is equal to 49. Okay, so what is 49? X equals 49. Do I know what x is? Some of you didn't define your variables. They just got x equals 49. I don't know where that goes. But remember, we defined our variables. Thank goodness. Let's look over here. What is x? X is the number of nonfiction books. So 49 is going to go right there. And to find your fiction books, I'm going to do the easier way. I'm just going to do 289 minus 49. Okay, that's just 240. Okay. And that's it. All right, so that's question 10. Now on to question 11. Okay, so question 11, there's 4 equations that they want us to solve. So let's just go through this kind of, as swiftly but efficiently as possible. Okay, so we've got minus 2 is equal to 4 plus x over 3. Let's kind of draw a little line down here so we see both sides of my equation. Okay, so where's my x? That's over here. Okay, circle that. We've got 4 plus x, that's happening first, then we divide by 3. So how am I going to undo the operations in reverse order? I'm going to have to get rid of that division by 3 first, because that's the last thing that happened, right? So I'm going to multiply by 3. I'm going to multiply this side by 3, okay? So these cancel out. On the right, I just have 4 plus x. On the left, I've got 3 times minus 2, that's minus 6. And now, to undo this addition, I'm going to subtract 4 and subtract 4. That goes away. On the right, I just have x. On the left, I've got minus 10. Okay, so x equals minus 10. Question B here. Okay, we've got 4x plus 21 equals minus x minus 6. Nothing to distribute, nothing to divide. Okay, no like terms on the left, no like terms on the right. But, okay, this is a double-sided equation. So I have to eliminate one of these x's. So which one should I eliminate? You pick, okay? But I think I want to get rid of this one. So let's do plus x here. Let's do plus x over here. Okay, let's draw this little line down here. So this cancels out. On the right, I still have that minus 6. But on the left, 4x plus x is 5x plus 21, right? Now, remember, this is being multiplied. I want to get rid of that 21 first. So I'm going to minus 21, that goes away. 5x is equal to minus 27. Okay, let's continue on over here. So last step, we have to divide by 5, and so we get x is equal to minus 27 over 5. And that's not going to divide nicely, so we're just going to leave it like that. Okay. Now, oh, actually, let's put that in a little box here, like this. Okay. Now, on to question C. So, we've got some brackets. That's a big hint that we should distribute. Remember what distribute means? It just means we're going to draw little rainbows from the number in front of the brackets into everything in those brackets, and we're going to multiply. Okay, so don't distribute to things outside the brackets like that. Okay, please don't do that. Just draw your rainbows from the number that's in front of the brackets to the things inside the brackets. Okay, so 2 times 4 is 8, 8x. 2 times minus 5 is minus 10. Got that plus 8. 5 times x is 5x. 5 times 6 is plus 30. Okay, and that's our first step, was to distribute. Now let's combine like terms. Okay, we've got some like terms over here. That's going to give me 8x minus 2. Let's actually draw a little line. Okay, and that's going to be equal to 5x plus 25. Now, okay, let's draw that a little nicer. Now, we've got a double-sided equation. We have to get rid of one of these x's. So pick which one you want to get rid of. I'm going to choose to get rid of that 5x. Okay, so minus 5x minus 5x. That goes away. 8 minus 5 is 3. I've got 3x minus 2 is equal to 25. Now we can solve. These are being multiplied. That's being subtracted. I'm going to get rid of the subtraction first. Okay, so let's plus 2 plus 2. That goes away. We get 3x equals 27. And now we divide by 3. Divide by 3. X is equal to 9. Okay, now question D. So step 1, distribute. So we draw little lines. Okay, we got 8x plus 48 is equal to minus 5x minus 4. This is a double-sided equation. Let's get rid of one of them. I'm going to get rid of this minus 5x, so I'm going to add 5x. Add 5x. That goes away. 8 plus 5 is 13. X plus 48 is equal to minus 4. Okay, let's draw those little lines down here. Okay, and now we're going to get rid of that plus 48, so minus 48 minus 48. That goes away. Minus 4 minus 48 is minus 52. And on the left, I still have 13x. So to get rid of that 13, I'm going to divide by 13 because it's being multiplied to my x. And I'm just left with x. That's a terrible looking arrow. X is equal to minus 4. Okay, 52 divided by 13 is minus 4. Negative 52, I mean. Okay, so always just think about what's your inverse operation. That's how you're going to slowly get rid of your variables when you're solving. Get rid of the things that's on the same side as your variable while you're solving. Okay. All right, so that's question 11. Question 12. So now we're dealing with some geometry here. So we know the dimensions of an arena are 200 meters by 25 plus n meters. Basically meaning the length and the width are given to you. Okay. Now, if the building covers an area of 17,000 meters squared, they want us to find the value of n. All right, so let's do this real quick. We know the area of a rectangle. Remember, the area is, that's an r by the way, is length times width. So we know the length and the width. Let's write them out. So length is 200, width is 25 plus n, and that's equal to my area, which is 17,000. Okay, now 25 plus n, that's happening first because of bed mass, right? Inside the brackets first. Then we multiply by 200. So let's undo it in reverse order. I'm going to divide by 200, divide this by 200. Draw a little line here. Okay, that's going to go away. We get 25 plus n is equal to 17,000 divided by 200 is 85. And now we have n plus 25. Let's get rid of that 25 by subtracting 25 on both sides. Okay, so that goes away. N is just going to be equal to 60. Okay, now on to question 13. So same idea. All right, so we've got the dimensions of the deck. So let's just rewrite that. Okay, we got length times the width, 2x minus 7. That's going to be equal to 351. Same idea, divide by 27, divide by 27. We get 2x minus 7 is equal to 13. Now remember, this is being multiplied, the 2 and the x, and then we're subtracting 7, so we're going to get rid of that 7 first. Plus 7, that goes away. We get 2x is equal to 20, because 13 plus 7 is 20. Now we're going to divide by 2, that goes away. X is equal to 10. Okay, so I know x is equal to 10, but the question is asking what is the perimeter of the deck? Okay, it's not asking for x, it's asking for the perimeter. So how do I find the perimeter? I know the perimeter is the length of around the shape. So basically, I know what? I know this is 27, that's good. I know this is 27, that's good. But I don't have these two lengths. But I can find that by substituting x equals 10 back into here. Okay? So 2 times 10 minus 7 is going to be 20 minus 7, which is 13. So this length is 13. That length is 13, right? And so now to find your perimeter, we're just going to do 13 plus 13 plus 27 plus 27, and you're going to get 80 meters. And that is your perimeter, okay? It's just a length around the rectangle. Now, let's look at question 14. So we're given a pentagon. It says the measure of the apothem of this regular pentagon is 10 centimeters. Remember, the apothem is the distance from the center of your regular polygon to the center of one of its sides. Okay, so that dotted line there, it's a distance. So we know that's 10 centimeters. It says the area of this regular polygon is 300 centimeters squared, and the side length of this regular polygon is represented by the algebraic expression x plus 3. So we don't know what the side length is, so we're just going to represent it with x plus 3. Why x plus 3? I don't know. They told us it's x plus 3, so let's use that. But we want to know what is the numerical value of x. Okay, so remember the area of a regular polygon, the formula for that is perimeter times apothem divided by 2. Let's fill out what we know, okay? Because luckily they already gave us that equation. They set it up for us. So the area of the regular polygon, we know what that is. That is 300, so let's put that right there, equals the perimeter. What is a perimeter? It's the length around the shape, okay? Now, if we knew all the sides, we can add them all up, okay? And luckily, because this says it's a regular pentagon, I know that all the sides have the same length. So I could do x plus 3 plus x plus 3 plus x plus 3 plus x plus 3 plus x plus 3. Sure, I could do that, but that takes a long time. And remember, multiplication is just repeated addition, right? So instead of finding the perimeter by adding x plus 3 to itself 5 times, I'm just going to say the perimeter is 5 times x plus 3. So I've got 5 times x plus 3 times the apothem. They gave that to us. It's 10 centimeters. And then divide that by 2. Okay? Now, let's deal with our numbers real quick. Okay? I know 5 times 10 is 50. Okay, so I've got 300 is equal to 50 x plus 3 over 2. Right? I know 50 divided by 2 is just 25, so I've got 300 is equal to 25x plus 3, right? And then now I could divide, well, okay, before I say divide, let's think about it. X is adding to 3 first, because that's what's happening in the brackets. Then we're multiplying to 25, yeah. So the last thing that happened was the multiplication by 25. That's the first thing I'm going to undo. I'm going to divide by 25, divide by 25. That goes away. 300 divided by 25 is just going to be 12. That's equal to x plus 3. Now, x is being added to 3. To get rid of that plus 3, I'm going to minus 3. I'm going to minus 3. That goes away. We're left with 9 equals x. All right. Now, on to the long answer questions. So we know Alex, Brianna, and Carlos are working on a consulting project. Their hourly rate is $25. Now remember, for these types of questions, okay, read the question very, very carefully. Make sure you're writing things accurately, okay? And to define your variables, okay? I beg you, please define your variables. I guarantee you, very little effort, high reward. I don't see why you wouldn't want to do it. Just define your variables, please, okay? It makes a world of difference, all right? If you want to succeed in this course, please define your variables, all right? Like, I can't repeat it enough, okay? If you don't, you're just setting yourself up for failure, and I can't really do anything about that. So, Brianna worked 5 hours more than twice the number of hours Alex worked. Okay. 5 hours more. Remember, 5 hours more than means we're going to add 5 to something. What am I adding 5 to? Twice the number of hours Alex worked. But do I know how much Alex worked? I don't. They don't tell me that. So I'm going to say the number of hours that Alex worked. Let's call that X. Let's just say that's my X. Okay. So let's just like right here. Okay. Well, luckily for us, the names are A, B, and C. They start with A, B, and C. So I'm just going to say A for Alex. Okay. Let's say that's X. Number of hours worked by Alex is just X. Now, let's look at B. Brianna. Brianna worked 5 hours more than twice the number of hours Alex worked. So I'm going to double the number of hours Alex worked. How many hours did he work? X. How do I double X? It's just going to be 2X, right? Then we add 5 to it, all right? So luckily we've defined what that was. We know the number of hours Alex worked, so we can double it, then we add 5 to it. Now, let's look at Carlos. Carlos worked 7 hours less than. So remember, 7 hours less than doesn't mean we're doing 7 minus something. That means we're subtracting 7 from something, okay? If you see 7 with like a number less than something, that is what's being subtracted, okay? Again, something that you should, it's just like a logical kind of gap, okay? It's just, you have to remember this, okay? It's, you have to remember that when you're doing less than something, you're subtracting that thing from something else. Okay, it's not 7 minus, it's something minus 7. Okay, so we want 7 hours less than what? Less than 3 times the number of hours Alex worked. But I know the number of hours Alex worked. We defined it over here. We defined my variable. That's X. Okay, so it's 3 times the number of hours Alex worked. That's 3X. And then we subtract 7 from it, minus 7, okay? So now we've defined my variable. I've defined these two expressions as well, okay? Together they logged 490 hours. What does that mean? That means that if you put all their numbers, their hours, together, we get 490. It's not this. It's not just Brianna who got 490 hours by herself, okay? It's not Carlos who got 490 hours by himself. So it's not 3x minus 7 equals 490. All 3 of them, okay? So don't do this either. Don't do 2x plus 5 plus 3x minus 7. It's not just the 2 of them. It's all 3 of them. All 3 together, okay, logged 409 hours. So you have to take all 3 of them, and when you add the number of hours worked by Alex, which is X, plus the number of hours worked by Brianna, which is 2x plus 5, plus add that to the number of hours worked by Carlos, 3x minus 7. That's equal to 490, okay? That's your equation. Now, let's solve. There's nothing to distribute. There's nothing to divide. Are there like terms? Let's draw a little line here, okay? I have my right side, nothing's going on there. On the left side, I've got x, I've got 2x, I've got 3x. 1 plus 2, right? If there's nothing in it, it's a 1. 1 plus 2 plus 3 is 6x. 5 minus 7 is minus 2. That's equal to 490. All right? Now, we could just solve this like our multi-step equations, right? How do I do that? 6 times x minus 2. Multiplication happens first, then subtraction. Subtraction is what we're going to undo first. Plus 2, that goes away. 6x equals, I'm writing off the screen here, 6x equals 492. And now we divide here by 6, divide here by 6, that goes away. X is equal to 82. Okay, x equals 82. What does that mean? What is x? Is that the number of hours worked by Alex, Brianna, or Carlos, right? Because the question says, how much money did Carlos earn in July? And I know their hourly rate is 25. So should I just multiply 82 hours by 25? Should I do that? Is this the number of hours worked by by Carlos? No, because x is Alex's number of hours. Carlos is 3x minus 7. So to find out how many hours Carlos worked, I have to take this 82 and substitute it into his 3x minus 7. So 3 times 82 minus 7 is going to give you 239. And now that's how many hours Carlos worked. And we're going to multiply that to 25, okay? And you can do like little brackets here just so you don't get confused with the x's. 25. And that's going to be 5,975. That's how much he earned in July. Okay. Hope that made sense. Now let's go on to the next question. The sports tournament. So a sports company is sponsoring a tournament featuring hockey, basketball, and wrestling. Very diverse. So there will be a total of 240 athletes in the tournament. Okay, so a total of 240. Already, that's telling me what? That's telling me that if I find the number of athletes in each of those sports, hockey players, basketball players, wrestlers, if I add those three numbers up, I should get back to 240. Because in total, there's 240 athletes participating in the tournament. Now, the number of basketball players is 16 less than. What does that mean? Once again, it's not 16 minus, okay? I can't say this enough. It's not 16 minus something. It's something minus 16. We're taking 16 away from something. What are we taking 16 away from? What are we subtracting 16 from? We're taking 16 away from triple the number of wrestlers. So we have to triple the number of wrestlers and then subtract 16. Do I know the number of wrestlers yet? Do I? No, I don't. I don't know the number of wrestlers. I'm going to call that X. Okay, so the number of wrestlers, number of W, is X. That's it. Number of wrestlers is X. I've defined my variable. I know what X is. Now, the number of hockey players... Oh, actually, let's go back to basketball. Basketball is 16 less than triple the number of wrestlers. So number of basketball players, I'm going to triple X, then take 16 away from that, right? I'm subtracting 16 from triple the number of wrestlers. What is the number of wrestlers? X. I want to triple X. I want 3X. Then I minus 16. Okay, number of hockey players. What is that? The number of hockey players is 4 times the number of wrestlers. I know the number of wrestlers. I've defined my variable. I know X is the number of wrestlers. How do I get 4 times the number of wrestlers? It's just 4 times X, which is just 4X. Okay? So I've defined my variable. I've defined how many basketball players and hockey players there are, just kind of using X's. Okay, it's okay that I don't know what those things are yet. I don't know what X is. I don't have a number. That's all right. We're going to find it soon using an equation. So like I said before, I know there's a total of 240 athletes. When you see total of a number, okay, total of 240, that's a big indication, a big hint that that's what you're going to use for your equation, okay? So I know in total there's 240 athletes, which means I take all 3 of these algebraic expressions. I take the number of wrestlers, which is X. I take the number of basketball players, 3X minus 16. I take the number of hockey players, 4X. I add them all up together, and that's going to equal 240, okay? I take the number of wrestlers, basketball players, and hockey players. I add them all up. Doesn't matter if I don't know what X is. I just add them, those things that I've written here. And that's going to be equal to 240. Now, draw the line here. Let's solve. There's nothing to distribute. There's nothing to divide. Do I have like terms on the left? I do. I have X. I've got 3X. I've got 4X. 1 plus 3 plus 4 is 8. X minus 16. That's equal to 240. Now, this is being multiplied. That's being subtracted. I want to get rid of that subtraction. I'm going to add 16 on both sides. That goes away. I get 8. X is equal to 256. Last but not least here, divide by 8. Divide by 8. That goes away. Okay, so X is equal to 32. What is X? X is the number of wrestlers. There's 32 wrestlers. Okay? And so how do I find the number of basketball players? I'm going to take that 32, that X, I'm going to plug it back into my X's up there. Okay? So the number of basketball players then, is going to be 3 times 32 minus 16, and that's just going to be 80. And hockey players, let's do a little hashtag number of hockey players, is going to be 4 times 32, which is equal to 128. So there's 128 hockey players, 80 basketball players, 32 wrestlers. But the question's not done yet. The question wants to know how many bottles does the company need to prepare for the entire tournament, it also tells us that each athlete will be given 2 bottles of a sports drink for every day of their tournament. The wrestlers will compete for 6 days. The basketball tournament will last 9 days, and the hockey players will be playing for 11 days. So let's change colors here. Okay. So let's think about the wrestlers. Each wrestler should get 2 bottles for every day that they compete. So 32 wrestlers, they get 2 bottles for every day they compete, and they're competing for 6 days. So 32 times 2, right? 32 players times 2 bottles per wrestler for 6 days. What does that come out to? That comes out to 384. I'm going to do the same thing for the basketball players. I've got 80 basketball players. I should multiply that by 2 so that there's 160 bottles every day. And how many days is the basketball tournament lasting for? 9 days. So 8 times 2 times 9 is 1440. Last thing, same for hockey. I've got 128 hockey players. Multiply that by 2. Multiply by how long they're playing for, 11 days. That's going to be 2816. I add these things up, I get 4,640 bottles with a little smiley face. Okay. Now, as an added bonus for those who kind of stayed till the end of the video, here's some questions that might be just a little bit similar to the ones that you might see on your test. I don't know. But if you add 28 centimeters to the perimeter of a regular hexagon, you will end up with 40 centimeters. What is the length of each side of the regular hexagon? Meaning, once again, remember regular is, it just means that all the sides have the same length and all the angles inside their polygon are the same. Which means if I know that the length of each side is x, then this is x, that's x, that's x, that's x, and that's x. Okay? So let's go back to the question now. Read it again. You have, if you add 28 centimeters, so we're adding 28 centimeters to something. What are we adding 28 centimeters to? We're adding it to the perimeter of a regular hexagon. So what is the perimeter of a regular hexagon? It's just the length or the measure around the entire shape. So I could do x plus x plus x plus x plus x plus x, or I could just do the number of sides times x. Okay? So I do the number of sides times x. I add 28 to it. 6 times x plus 28. What does that give me? It gives me 40 centimeters. And then you just have to solve this. That's all this question's asking you to do. Okay? Just find out what x is. If I look at question 8 now, okay? So basically, this bonus, I'm just giving you a setup, but I'm not really telling you how to solve it, okay? Next question, question 8. Consider the following triangle. Its height is 2x plus 7. The base is 118 centimeters. The area of the triangle is 7,493, okay? So basically, we want to find out what x is. We know what? We know the height, we know the base, we know the area of the triangle. What is the formula for the area of a triangle? It's base times height divided by 2. That's the area. Okay, this looks like a plus, so I'm just going to put a little dot. Base times height divided by 2. Do I know the base? Yes, the base is 118. The height, do I know the height? Yeah, it's 2x plus 7 divided by 2 equals what? The area. The area is 7,493. Now all you have to do is solve this. That's it. Find out what x is. That's your answer. Okay? Alright, I guess that's gonna be it for this video. Hope that helped.